So our project is mapping risk in Texas aquifers. Me, Aziz, Azusena, and Bandhan is our teams. So our objective is to use logistic regression to develop and test aquifer vulnerability model using actual data. Use Naive Bayes Classifier to develop and test an aquifer vulnerability model using actual data, and then KNN with the prediction of LR and NBC to obtain a uniformly graded database of vulnerability values covering the entire domain of the aquifer, and finally to create a single final vulnerability map the aquifer by integrating the results from LR and NBC model in a meaningful manner. Here is the map for Seymour Aquifer county-wise in Texas. We can see the county name like Kent, Baylor, Collingsworth, Fisher, Hall, Jones, Knox, Stonewall, Motley from this map. And this is the website from where we collected data, and these are our variables in total units. What if we are, I mean, this is our resources what we used here.
Hello, my name is Azucena, and I'm going to continue with this presentation. So, in this step to collect this data that we find found was about the variable y, that is dissolved arsenic. And for the variables independence, we have the well depth and also the total dissolved solids. How we collect this data? Well, from the website that my teammate explained, in this website we selected the aquifer Seymour. We selected all the counties that are inside of this aquifer, and we selected for the water quality parameter the arsenic dissolved and also the total dissolved solid. And as coordinate format, we selected decimal degrees. So we find out that in this table, we have the different wells that are inside the aquifer Seymour. We have the coordinates, we have the different counties, we have the aquifer codes. As you can see, we found that there are unknown aquifer codes. So we remove this data that doesn't have these aquifer codes. So after we found these tables, we can see now that we found 5 different aquifer codes, which are inside of the Seymour aquifer. This list of national principal aquifer codes and names are fixed values assigned by the National Water Information System. Um, these aquifer codes are identified by a geohydrologic unit code, which is a 3-digit number related to the age of the formation, followed by a 4 or 5-character abbreviation for the geologic unit or aquifer name. So we could select all the aquifer codes that are inside the Seymour aquifer. And we can see also in the second column all the counties that are inside that are included in the aquifer. And here also you can see the 2 websites that we um, found this information to see if the aquifer codes that we were seeing in these tables are important to us. So after we collected this data, we developed the the models As we said before, the logistic regression model, also the NBC model, and the KNN model.
Okay. So this is the Seymour map in the QGIS. We develop a Seymour map in QGIS as we collected the data of the aquifer data. This aquifer data as a shapefile, and the other data, other like the CSV file here. We have this coordinates here, latitude and lat and long. So we use that and import the CSV file into. First, we did like aquifer file and select the same or aquifer in that, and then filter it out. Then we imported the CSV file into that QGIS, and we make a geometry out of it and plot the wells location on the Seymour app. As you can see, there are many wells on the Seymour aquifer. So after this, we developed, by plotting the wells. After this, we develop a regression model that is here. We develop in the Jupyter notebook. So we develop a logistic regression, then the Naive Bayes regression, and we try to replicate those prediction into the KNN, and by using KNN, we try to obtain some vulnerability test. So for that, we have to load the libraries here, all the required libraries. Then we change our working directory to our file path. Then we load the pandas data frame. So this is the CSV that we make out of, like deleting the unknown wells and unknown wells and the no data values. So here you can see it consists of, we have two different CSV file. One is for total dissolved solid and one is for arsenic. So arsenic values are here at the last, and we have two CSV file for that. So we just merge these two files with the well ID. First we pick the maximum value of the more than one readings of one well, so that we can so by doing that, we get the state well number as a primary key, and total dissolved solid, we got like more than 2000 wells for total dissolved solids, and there is only 144 data points for the arsenic value. But after picking this maximum values and discarding the unknown wells, we get only 70 values. And we also did for like Sergo data also, but after adding the Sergo data, we ended up with the only 15 wells. So we cannot use that for logistic regression. So we did it like for total dissolved oxygen, total dissolved solid, and the well depth. So these two are our independent variable, and our dependent variable is arsenic. So we are trying to predict the arsenic here, and this is the geometry. It is getting from got it from the Sergo data. So let's start with the core. So here we get the new column of accidents, which will tell you that we put the threshold of 3, value of 3 for the arsenic concentration. So which are the arsenic concentration? Wells has concentration of arsenic more than 3 will fall in a category of 1, that is means accidents. Either it will or it will fall in category 0, that is not accident. So we choose that accidents, and then we choose our x variables. This is our y variable, and we split the data in training and testing. So this is our test size is 30%, 0.3, and this is how we lower the logistic regression, and we check the linear regression model accuracy and the confusion matrix. So we can see here this is a confusion matrix which is true negative, then third one is false positive. So just like that we get the 0.61 LR model accuracy. Then there is NBC model. We predict the model using NBC. So there is NBC accuracy is 0.76, and we try to do something with the KNN, which will covered by my teammate Aziz.
Yeah. Aziz, after what my colleague has said, so the next thing we did was the KNN, that's the K nearest neighbors. So how we did this was that we used the logistic regression and the Naive Bayes classifier models to make prediction on the testing data sets, and we now then this prediction we use them to generate a uniformity graded data sets of vulnerability values for the seymour aquifer, and then we now decided to evaluate the performance by using the accuracy metrics. And then after then we moved to the single vulnerability map. So in doing this, we splitted the data set into training and testing. So we trained the logistic regression and the Naive model on the training data set, and then we use the model to make a prediction for the testing data. And we then move forward to using some weights to combine the LR and NBC prediction. Then we now finally reshaped the combined prediction into a grid to create the final vulnerability map. So in conclusion, based on the literature in which we read, we realized that the seymour aquifer is actually a critical source of drinking water for communities in North Texas. So in conclusion, our studies suggest that the seymour aquifer is vulnerable to contamination from superficial sources, and mapping the susceptibility of the aquifer to contamination can help guide land use and um, and groundwater management decisions. And the area can also the area can also be prioritized for protection.
As Aziz said, thank you, Aziz. As Aziz said, we have to we have many future work to do, but due to time conflict, we cannot able to do that. So as overall, we can see that arsenic is a hazardous material, hazardous contaminant, and now it is usually found in the wells, in the groundwater, and the EPA limit for arsenic in the drinking water is like 10 ppb, that's parts per billion. So it cannot be exceed more than 10 ppb. But we have data sets of only 70 unique wells, so we cannot do that, and the only two wells out of 70 wells are exceeding the limit, so we cannot use that limit for linear regression. For logistic regression, here you can see here x is greater than 3, so we did it so that's why we did it for x greater than 3. That then and then we can do like 50 if 45 percentage of training and testing data. So and arsenic is found by the volcanoes and the commercial and industrial processing from mining. So this is important to predict the arsenic accidents. Thank you.